Hello everyone, welcome. Today let's start with the Domain 5 amendments, and the first topic in the Domain 5 amendments which we are going to discuss is Industrial Control System ICS. Now this topic, Industrial Control System, was there in the old syllabus also. However, this topic was there in domain number 1. Okay, second thing, this was not at all important, in the old syllabus, and that's the reason, they never asked, any question from this topic since the past 5 years, because as you might be knowing that the amendments for CISA exam, normally they bring amendments once in every 5 years, but we have never seen question on this topic since, the uh, past 5 years. So it was there in domain number 1. Okay, it was not important. The coverage was less as compared to the new syllabus. Okay, so in the new syllabus they have added slightly more content for this topic as compared to the old syllabus. Number 4, they have moved this topic to domain number 5. So previously it was in domain number 1, which didn't made any sense, right? Because that is a domain for auditing, right? So right now, they realized their mistake, and they shifted this topic from domain number 1 to domain number 5. They added few areas, they added few content here, and since, as I've told you, it was not at all important in the old syllabus, we have never seen a question on this topic. But right now, because of these changes which they have done, this topic becomes important for the new syllabus, right? So old syllabus, anyways, it doesn't matter as of now, but for the new syllabus this topic becomes important, and this topic is actually very interesting and easy topic as well. So nothing to worry about. Do not fear about this topic. We will make this topic extremely easy, and you will really enjoy. Okay, so the topic name is Industrial Control System. There are three words: industrial, second word is control, the third word is system. So if you understand these three terms, right, you will actually understand the logic, the meaning of this entire concept. So when we say industrial, okay, just a minute, yeah. So when we say industrial, it means factories, your power plants, your refineries, it could be any manufacturing setup, any manufacturing industry, right? So here we are not talking about our general business, our service sector industry, or the trading industry. Here we are talking about, the manufacturing setup, the factories, the power plants, refineries, right? So, with this term you at least understand, right, that we are talking about some kind of systems which are for industrial use, right? The second word over here is control. Okay, second word is control. When we say control here, it means, you need to manage, we'll talk about, having commands regulating the behavior of machine runs. We need to make sure that, the machine in this industries, they run safely, they run efficiently, they run smoothly. Okay, so we are talking about the system controls, which are used in the industry. Okay, now with the word system here, we say system means it could be software, it could be dedicated hardware, right? Like specifically designed for special purpose, especially for this industrial use. Okay, it could be your sensors, your controllers, dedicated hardware, right? So basically the main reason, why we are making these kind of system is to automate, is for the automation of the manufacturing process, right? At least with this thing, you get a basic idea, basic overview of what we're going to learn. Definitely we'll be seeing various other aspects over here, but at least you must understand the overview of this topic, before we proceed ahead. So basically industrial control systems are the systems, I mean, here we'll be talking about the system controls, for these softwares or these dedicated hardwares which are specifically designed for industrial purpose or the industrial use, right? All right, so let's proceed ahead. So basically, here in industrial control system, as the name itself tells you, okay, right? It's not a rocket science, even if you just read the term, you will get a basic understanding of the basic idea. As the name suggests, it's an automation of the manufacturing process of the machinery used in the manufacturing industry. Okay, so for example, today you have a plant and machinery where you will have to configure the daily run in terms of what is the quantum of raw material that will come into the plant and machinery, what is the activity that each plant and machinery will have to do, and the technical specifications like the size of the diameter, or any other parameter that is required for the plant to be able to work properly. So today you have a separate computing system which takes care of all these things, which we call it as industrial control system, right? Now industrial control system, they also popularly, they also call it as SCADA system. What is SCADA system? The full form is supervisory control and data acquisition systems. Data acquisition systems. So basically, you will find such systems linked with plant and machinery in manufacturing setup, or with the power grids, power distribution facilities, right? You will not find them in the service sector, right? You will not find them in the other industries, correct? Because these are exclusive, systems to manage the plant and machineries or the workflow in the industry, to control the machines functioning, or to automate the machine functioning, right? So I don't know, like, if you have ever had an opportunity to look into to go into a plant and machinery in a manufacturing setup, you will see that the operator of the plant and machinery would have been given a separate console. Okay, so operator normally, they have been provided with a separate console where he will go and configure a few things on the plant. And again, that is a constrained interface. So what do we mean by constrained interface? So basically here there will be what, very limited interface. And if you look at the keyboard also, the keypad, that it will be what, that it will be a very robust keypad, robust keyboard. Okay, I'll show you some practical things also over here. So robust keypad or robust keyboard. Why do we need robust keyboard? Because you can fairly expect a lot of dust, you can fairly expect a lot of grease, you can fairly expect a lot of oil leakages in these kind of scenarios, and your normal keyboards will not work, right? So let me show you some, these keypads, how it looks. Just a minute. Yeah. All right, so as you can see in the screen now, so I have just opened a website, organization, who deals with these kind of keypads, these robust keypads, right? So you can see this is how it looks like. So even they have mentioned the same thing, which we have discussed, right? So industrial machinery and equipment often require keypads and human machine interface that are rugged and built to last in tough environments and extreme temperatures, right? These custom industrial keypads need excellent tactile response, which also being environmentally sealed from water and dirt, and the ability to withstand even abuse. So for industrial control, we typically recommend a rubber keypad or a membrane switch due to their reliability, right? Ability to seal the, I mean, basically what they're trying to say over here is that, the thing which we have just discussed before, right? We want a robust keypad over here, right? So just wanted to, basically they deal with other, such keypad solutions as well, right? Let's go back to our discussion. All right. So basically, having said that, these are today susceptible to the same kind of risk like any other application software. Okay. So, when we say industrial control systems, don't keep this thing in your mind. Okay, industrial control system are not your normal system. The way there are risk in the normal application software, right? The normal systems, the similar kind of risk or the threats also, is present in these kind of systems as well, right? So these are susceptible to the same kind of risk like any other application software. However, they are usually in a closed user group. Okay, usually they would not have connectivity with the external network, or you can say there would be what, there would be you can say there would be what? There would be okay, less connectivity, or less to, or you can say no connectivity to the external network, or to the, you can say, the internet, right, to the external network. So basically they say they are less susceptible to threats. But mind you one thing, if I say it is less susceptible to threats, that doesn't mean there is no risk. In fact, here the impact can be huge. If, let's say, tomorrow there is an attack on these systems, you can't even imagine the impact that it will have. In fact, we'll see the practical example, in the past, where these kind of incidents have happened in the real world, in these industries, right? We will look at those examples also very soon, right? So when we say there are, that there is less susceptible to threats, you can't rule out the threats on such systems, and also, these facilities will normally be self-contained, so self-contained, as we have discussed, it will not have connectivity with the internet or any other network, because it is programmed to manage only those machines for which it is configured, and not for, the external access. Okay. However, again, as we have discussed, you can't rule out, because in fact, more than the external threats, there are also what, there are internal threats. Okay, or the wrong configurations which can lead to loss of raw materials. Sometimes in the worst case scenarios, there can also, it can also cause harm to the persons who are present in that particular facility, who is accessing these plants and machinery. So I would like to show you one example over here. Right. So, if you look at this, just a minute. Okay. All right. So, you can see the news saying robot kills workers at Volkswagen plant in Germany. Right. So, the contractor was setting up the stationary robot, where it grabbed and crushed him against a metal plate at, the plant in Germany. Right. So, what happened was here. Okay. The 22-year-old was a part of the team that was setting up the stationary robot when it grabbed and crushed him against a metal plate. Okay. He said initial conclusions indicate that what? Human error. What? Human error. So, the thing which we are right now discussing, that can be what? That can be internal threats also. Sometimes, it could be deliberately, or it could be non-deliberately, or, non-intentional, right? So, these kind of, things, like when we talk about the internal threats. In fact, even if we talk about the normal systems, in our day-to-day, like, organizations, we say, when we say internal threats, your employees can also be a risk factor. Sometimes it could be, non-intentional, but sometimes it can also be what, intentional thing, right? So here also the same thing, right? So sometimes we say human error, but sometimes, who knows, it could be a deliberate, action, right? So on the basis of the initial, investigation, they said that, it indicated that human error was to blame, rather than a problem with the robot. Why? Because robot can be what? Robot, it will only do what you ask, these robots to do, right? So basically, it can be programmed to perform various tasks in the assembly process. He said it normally operates within a confined area at the plant. Again, the thing which we discussed, confined area, right? Grabbing auto parts and manipulating them. Okay, another contractor was present when the incident occurred, but was not harmed, right? So just wanted to let you know that, the, impact can be huge, like, whether it is intentional, whether it is deliberate, whatever it is, whether it is internal, or whether it's external. When these configurations are manipulated, or are changed, when there is unauthorized change, the risk, I mean, the impact can be huge, right? So let's go back to our discussion. All right, so, today they say an error in an industrial control system can lead to loss of raw material. It can lead to some other issues, in manufacturing, but in worst case scenarios, it can even lead to what? Your human loss. right? So it can all of a sudden release what polluted materials into the atmosphere. There can be scenarios where things like poisonous gas can be released into the environment or into the water body. So the industrial control systems, though they are internal to the organization, they can cause a lot of damage if they are not configured and maintained properly, right? So basically, what they say, the risk relating to such systems, there can be unauthorized changes to the instructions, to the commands, right? So if they're not configured properly, it can also happen that the planet machinery will misbehave. It can damage, disable, or shut down the systems themselves. Inaccurate information can be sent to the operators who operate such systems, causing them to make inappropriate changes to the configurations. There could be unauthorized modifications, including malware. Okay. We will also see one example of the real world example of these kind of incident which has happened in the past, right? So today, what, a lot of big corporates or a big manufacturing industry, they have fear that their competitors might deliberately induce a malware into their industrial control systems. And in fact, we have had this scenario, right? So let me take you to the example. All right, so as you can see, malware discovered in German nuclear power plant. Again, so this is the old news, a 2016 news, right? So we can see a German nuclear power plant was recently discovered to be infested by a computer malware, right? So here, fortunately, there was not much impact. In fact, according to the initial investigations, the discovered viruses were not created to target power plants, but they were simply common malware variant. So basically the intention of these intruders was not to specifically target these industrial control systems right into these power plants, but basically they were simply common malware. But you can't imagine, right, if these kind of incidents, if it is specifically designed for these kind of industrial control systems, because we normally don't have much controls. The industry will not be focusing more into these areas. Why? You need to understand that why are we even studying this topic in a CISA? Why do we have to study this topic, and why this becomes important for the new syllabus, and why they can ask you question from this topic? Because understand one thing, that normally for the big industries, they'll not focus much into these areas, because their main focus will be in their normal IT environment, their normal IT infrastructure, their normal application software which they do use. And sometimes they might ignore these industrial control systems. They might say that, okay, since they are self-contained, they are not connected to the internet, that's why we don't have much controls over here. But as an IS auditor, when you go to the organization, when you go for the audit, you must understand that risk also, I mean, it is present in these systems as well. But if you don't have any idea about these systems, if you don't have any overview about these systems, you cannot identify the risk is there. So that's why it's important to for us to discuss this topic in the new syllabus, right? There's one more example. Okay, you can see an Indian nuclear power plant suffered a cyber attack, and this incident happened on in the year 2019 November, right? So here also you can say you can see that the nuclear power corporation of India limited, NPCIL, has now confirmed that there was a cyber attack on the Kudankulam nuclear power plant, which they call it as KKNPP, in Tamil Nadu, India, in September. The nuclear power plant's administrative network was breached in the attack, but did not cause any critical damage. So fortunately, there was no critical damage. However, it is important to note that the KKNPP plant officials had initially denied suffering an attack. Initially, they denied this attack. Why? Why? Because they told that these industrial control systems are stand alone and not connected to outside cyber network and the internet, and any cyber attack on the nuclear power plant control system is not possible. So this was their, like, that statement, during the initial investigation. So this is how this is what you need to understand. So even if, it was self-contained, even if, it was not connected to the internet, still, there was found to be a attack or malware in these systems. So, you can understand, how risky these systems can become, right? All right, just a minute. Okay. Okay, so what else can I show you over here? Okay, the most serious target, right? All right. So they have even discussed about the controls isolating the computer network from the internet won't protect against target attack. In the initial denial, the NPCIL stated that any cyber attack on the nuclear power plant control systems is not possible. The KKNP site director, stating that the totally isolated network of KKNPP could not be accessed by any outside network from any part of the globe. Hence, there was no question of, it being hacked. Even the second NPCIL statement emphasized that the critical internal network was isolated from the administrative one, okay, and by that implication, the internet, right? So this physical isolation of a computer or the local network from internet to prevent any outside breach is called an air gap. So this term, when we say, we are isolating this, from the internet, this term is called as what? This term is called as air gap. However, this security strategy can leave a nuclear plant quite vulnerable. The NPCIL statement thus reflects either a complacency about the cybersecurity. What is this word? Complacency. It means self-satisfaction. Just because it is not connected to the internet, we feel okay, we are secured, right? About the cybersecurity of Indian nuclear power plants or the ignorance of its network vulnerabilities, right? So air gapped nuclear facilities can be attacked. Air gaps can be effective against unsophisticated and untargeted cyber threats, but not against targeted attacks. Right? So targeted attacks can go beyond the network connections and generally leverage, right? So you can, you can have, you can go to this article to, understand more about this thing, right? So I think, yeah, there was one more news article. Again, it is linked with the same thing, right? India's response: India denied all claims of this cyber attack until a month after the incident, right? Mhm. What else we can see over here? India's outdated cyber protocols, right, for the nuclear power plants. So the way, okay, so it's yeah, so here you can see, in case the KKMP, the NPCIL did not believe a cyber attack was possible because it used an what? Air gap approach to cybersecurity, right? All right. So you can have, you can go through this article to, understand more about this scenario, right? So let's come back to our discussion. All right, so let's come back to our discussion. Okay, so, now you understand, right? So, if malware hits these industrial control systems, which controls a nuclear power plant, or, it could be any factory, industry, manufacturing setup, the end result is not just a system failure. It can lead to humongous amount of calamity which is unforeseen by any scale of operation. That's why, some of these critical industrial control systems like power grids, the industrial control system which are used to monitor the air traffic controls, these are all very, 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 very extremely sensitive systems. And, we say that, they might have less probability of malware because, the organizations may argue, the auditee, the organizations may argue that, they are less susceptible to these malware, as compared to the general application software, but you need to understand that the impact of them when such targeted attacks happens, it could be huge. It could be widespread loss of the damage. So even though the probability could be less, the impact can be huge. So if you remember in domain 2 we discussed risk is equal to probability into impact. So even though you need to you can say this to the organizations that even though the probability is less, but the impact can be huge. So overall, if you say the risk is also high. And you know what, when I say over here that the probability is very less, I don't say it is close to zero, right? There is a probability. Okay, I mean, if we say it is less, that doesn't mean that there is no probability that can occur, right? There is a probability of these systems, being exploited by the malwares or by the vulnerabilities, right? So there is a probability, right? But what I'm trying to say over here is that the impact can be huge, right? It could be unimaginable. All right, so we have seen, all these risk in this industrial control system, and that's why we will need what? We will need controls also. And as I have, spoken about this, that this is not way different than the other application softwares. Okay, so even though we say that the industrial control system, their use is restrictive, they have special use, they have special purpose, they are used in industries, right? But all the controls, whatever it is applicable for the other application software, or the other IT infrastructure, the same controls is required over here as well. So when we say controls like firewall, controls like IDS, IPS, having your business continuity plans, your disaster recovery, all these controls, whatever controls we have discussion, for the other IT environment, the same controls is applicable right over here as well. Okay. And apart from this, we need to make sure that this particular environment is isolated. So basically, it should be isolated from the other network, so that let's say tomorrow if there is some malware in the other network or the other systems, those malware or those vulnerabilities should not come here, because there, see, impact will be high, but in both the scenarios, right? But here the impact will be huge, as we have seen earlier, right? So here we also make sure that there is isolation and the network segmentation, right? And then we also see, I mean, there is one more control which is very much common, which is physical restriction, to these area or these rooms. So if you ever visit any such plant and machinery, you will find that there will be a separate room, and there will be physical access controls, so that unauthorized person do not have access to these areas. And also there is no unauthorized changes to the configurations of these systems, because if such thing happens, the impact can be huge, right? And then the way we discuss the other controls, like to of having security patches for the other application softwares, here also security patches needs to be updated, right? These systems needs to be regularly monitored. There is a need of anti-malware, antivirus software over here as well, right? And then we have discussed, there is a need of your BCP or disaster recovery plan, right? Because understand one thing, if let's say for example, if there is a power failure or an outage, the industrial control systems may go down, and your entire plant and machinery, your operations can come to a standstill. So today these needs to be under a high availability, right? And in order to ensure that even if something goes wrong in an adverse circumstances, you are still able to manage the systems, or you have a fallback mechanisms by which you can handle them, you need to have proper your business continuity plans and disaster recovery plans in place, along with the procedures. There is always a need of giving the training and the awareness to the people who are handling these systems, because that also becomes important, because if the employees who are handling these systems, if they are not aware about these risk or these issues, they might never understand the importance of having controls, or the importance of regularly monitoring these systems, so that any abnormal activities or any unauthorized access doesn't take place. So it becomes equally important to train your employees the way we discuss about the importance of training, education, awareness in case of other IT infrastructure. The same is applicable over here as well, right? So with this, we finish this first amendment, which is industrial control system. Now we will also look at the theory part of what exactly is mentioned by the ISACA, right? We will see that theory now. Okay. All right, so let's look at the theory part of the industrial control systems security 5.2.3. Right, so basically here they have discussion of mainly about the ICS risk and ICS controls. Your ICS risk and the ICS security best practices. Right, so industrial control security. Just a second. Yeah, control system security. Industrial control system security (ICS) manage essential infrastructures like your water, power, transportation. As smart devices and IoT become more common, what are these smart devices and IoT? IoT is Internet of Things, all your this thing, smart ACs, smart TVs, it could be any physical objects or anything, if it is embedded with sensors, the softwares, so as to, have data exchange or data communication, that becomes a part of your IoT, Internet of Things. So with the, with these smart devices, and IoT become more common, ICS security is vital to protect against the emerging threats, the new threats which are coming in the market, right? So ICS risk, key risk in the ICS environment include poor security posture, focuses on physical security over the information security. So as we have discussed with the example, the attack which happened in the year 2016, 2019 also, the industries they were saying that since our ISIS systems are not connected to the internet, we don't have any risk, right? But that's not the case. So they were focusing mainly on the physical security and they were not mainly focusing on the information security. So you should always focus on both the aspects, not only the physical security but also the information security. In fact, the more the number of controls, the lesser would be the risk. There can never be one control which will bring down your risk. You'll need to have multiple controls so as to bring the risk to an acceptable level. And what are the controls we'll be discussing afterwards, right? In this part. All right, so improper input validation. Okay, what are input validation? Input controls, which we'll see in the domain 3. In fact, there are some attacks like your cross-site scripting, which we have seen in domain number 5 in the attacks, and there is SQL injection, which we have discussed in the domain 3 amendments also, right? So basically, wherever there are input fields, including your user ID, password, there the intruder, if they get the access, right, they can input malicious code, and they might even get the admin access to the systems, right? And it's not just about intruders, even the unauthorized persons, who are present in the industry, so as we have discussed, there can be internal threats as well as external threats. So even these internal employees, even internal workers, even they can be a risk factor. So you need to have what, a proper input validation. The input should be validated, right? Invalid inputs can disrupt the operation. If some wrong command is given, if control is being taken by the intruder, they can do anything with these systems, and we have seen, the impact can be huge, right? The next thing is the weak authentication. Insufficient authentication can allow unauthorized access. If there is weak authentication, right, unauthorized people can access into these systems, and they can do unauthorized changes, or unauthorized modification, or unauthorized alteration to these configuration, or to these data. And if that happens, the impact can be huge, right? Poor security practices, inadequate patch management and maintenance, embedded software vulnerabilities. Embedded software, there can be some ICS, some industrial control systems which can be embedded. Okay, but when I say embedded, embedded means attached or connected to the internet. So internet connected controllers are attack points, so they are the attack points. So let's say if the organization is having a lot of ICS systems, and let's say if one of the system is internet connected, and if there is some exploitation in that particular specific system, the other system might get impacted, right? So if one system is impacted, it can impact the other systems as well, right? Network design flaws. poorly designed network lacks security considerations. Then the seventh risk is what your aging technology. Older systems may not support the modern security. Now, these industrial control systems, these are in practice since past so many years. This is not a recent systems which we use. We are using these kind of systems in the industry since past very long years. And but because of the new emerging threats in the market, right, new risk coming in the industry, right, it can also happen that we are using the older system, and these older system may not support the modern security, modern things like your firewalls, your IDS IPS solutions, right? So in that case, we need to advise our clients to so as to change their systems, right? Non-compliance, failing to adhere to the security standards. Okay, there can also be a scenario where the industry could be having their own laws and regulation, industry specific laws and regulation, or maybe industry is operating in a country where they're having their own laws and regulation. If that's the scenario, they need to comply, or they need to adhere to those laws and regulations. And if they do not adhere to these laws and regulations, the impact is not only the penalties or the fines, but the impact is also what there can be disruption in the business operations, which we have discussed in domain 2 also. When you do not comply with the laws and regulations, the risk is not only the heavy penalties and fines, but you'll also have to end up you're doing a business, so there will be business disruption, because you cannot run a company without following the laws and regulations. You need to comply with those, right? Then weaker protocol. So since we have discussed, we might be using the older systems, and because of that, there can be older, the weaker security protocols in place. Lack of robust. So they have given the example of lack of robust encryption or algorithms in protocol. So it might also happen. So see, when I say that these systems, as we have discussed, for the other systems also, when we talk about the other IT infrastructure, there we discuss encryption for the data in transit, for encryption for the data in storage. So all those things applies over here as well. So all your this system configuration, these data, when these data are being transmitted to the other systems, all these should be having what, the data should be encrypted. And not only just encrypted, it should have what, it should have robust encryption in protocols, right? ICT dependencies. What are ICT? Information and communication technologies. What are these ICT? Technologies. Yeah. So ICT is nothing new. No, we have discussed. No, that there is IT infrastructure, and then we have what, ICS, right? The use of ICS is what, only for specific reason, right? Special purpose, industrial use. But we have discussed now about the other IT infrastructure, other IT architecture, right? We are all our other hardware, other application software, our internal network, your internet, all those things, right? So the organization will be having what, ICS. ICS is only for what, it is for a specific special purpose, right? But they will be having their own other application software, they will be having their other own other hardware, other network storage, and all those things, right? So all other assets, all other IT infrastructure, the internet, intranet, hardware, software, network, all those things together, it is called as information and communication technologies. Now understand one thing, that there could be a chance that your ICS is dependent on ICT. This is ICT, this is ICS. Your ICS might be dependent on ICT. If that's the scenario, then let's say tomorrow, if the intruder or the attacker exploit ICT, there is higher chances that your ICS will also be impacted, right? And vice versa. Okay. And also there can be single point of failure. So let's say if any hardware system fails, or if there is network failure in case of ICT, even your ICS will become inoperable. And if ICS becomes becomes inoperable, then the impact can be huge, right? So basically what they're saying is that your ICS can be ICT dependencies. Okay, so it is dependent on the ICT, right? Reliance on other technology can cause what? Instability, right? Now next thing is the third party risk, right? Now understand one thing, that if you are giving access to the third party in your industrial control systems, right? So for example, you might give temporary access for the ICS maintenance engineers, to the ICS maintenance engineers or the system integrators, right? They may occasionally require access to these ICS systems, right? So it also becomes important that the activities are being monitored, and they must also comply with our policies, because if they do not do that, that also creates a risk factor, right? So third party risk. So if you are giving temporary access, occasional access for the third party in your ICS, that also creates risk. External access can lead to breaches. Compliance issues we have discussed earlier. Also, non-compliance with the regulations can lead to penalties, and not just penalties, it can also disrupt your business operations, right? Next thing is your ICS best security practices or the controls. To improve ICS security, we need to have a lot of controls. Again, we have seen the past all the controls which is normally applicable to the ICT. Now we will use this term ICT, information and communication technologies. All these controls are valid for your ICS as well. Whether it's firewalls or IDS or IPS or encryption or anti-malware, antivirus, your BCP or disaster recovery, network segmentation, least access, all those things. Whatever it is valid for other systems, it is also valid for your ICS as well, right? So conduct the first one is conduct asset inventory. You need to identify and classify the ICS assets first, right? Then monitor network baselines, regularly check for the network anomalies, right? Any abnormal activities or events happening in the network with the help of the tools like IDS or your IPS, right? Segment networks, use segmentation to protect the networks. It is important, to isolate these networks, of these industrial control systems, so that it is having the least access to the external network or the internet. See, you cannot just have one control, and that's the reason we have discussed the example, the industry, in the example which we have discussed earlier. They were assuming that just because they are having the network segmentation, they don't have any risk at all, but that doesn't always work. So you need to have multiple controls so as to bring down your risk to an acceptable level, and one control can never fulfill your needs, right? Then the next is fourth one: implement least privilege, restrict access to the essential areas. You need to deploy IDS, IPS, use systems to detect and prevent intrusions, secure remote access, encrypt data for remote management, right? Then there is need of physical access and a physical security. Use physical security measures. Then the next thing is your implement redundancy, so as to have your business continuity or your disaster recovery. Ensure your backup systems are in place, right? Then hardening of the networks, secure networks with patches and block unused ports. Then develop incident response plan. Prepare for attacks with a response plan in advance, right? You need to prepare with the incident response plan. If tomorrow some incident happens, what will be your incident response plan? You need to define the roles and responsibilities. You need to have a separate team for it, who will be looking into this incident response plans, right? So whatever we have discussed in domain number 4, all those things is applicable for here as well. Supply chain security, assess vendors for the vulnerabilities. We have discussed on even the third party vendors. If they are having, if they need the access, we need to monitor their activities, right? We need to give them the least access, right? And also sometimes what happens is that when they try to connect their system with our systems, now it can be a scenario where their systems might be having a lot of vulnerabilities, right? So it becomes important to assess the vendors for their vulnerabilities, right? Okay, so with this we finish the industrial control systems risk and the industrial control systems best practices, right? There's one example also which we have given to you. Let me discuss that as well. Okay, imagine a company running a data center to manage its IT infrastructure. The data center relies on ICS to control cooling systems, power distribution, and physical security. Here are how risk and best practices apply. The risk is improper input validation. If input validation is weak, an attacker could send commands to change cooling settings, potentially overheating the servers. Now, best practice is implement robust input validation to ensure only valid commands are accepted, right? Then your weak authentication. If authentication processes are not stringent, unauthorized personnel might gain access to the ICS and manipulate the power distribution. Best practice use multi-factor authentication to enhance the security. Network design flaws. Poor network segmentation might allow an attacker to move laterally from a compromised server to the ICS. So, if there is poor network segmentation, and if other systems are, if your ICS is being connected to the ICT, if ICT is exploited, there is a chance that even ICS will get exploited, right? So it allows an attacker to move laterally from a compromised server to the ICS. The best practice is segment network or divide network using the firewalls and the virtual LANs to isolate critical ICS components. Then your aging technologies, your outdated ICS components might not support the latest security features, increasing the vulnerabilities. Best practices regularly update and replace aging technology. Okay, as we have discussed in the past, that we'll need to give advice that you might, now this has come to end of life. We say EOL means end of life. Okay, these systems have become end of, has have come to this end of life, and you need to replace these old technologies with a new technology so that it supports the newer security tools and mechanisms to ensure compatibility with the modern security protocols, right? Next thing is your compliance issues. Failure to comply with the regulations can lead to fines and operational disruptions. So not only fines, but also operational disruptions, which we have seen in domain 2 as well. Best practices: regularly review and update compliance practices to align with the current laws and regulations. By following these best practices, the data center can enhance its ICS security, ensuring reliable and secure operations while protecting against the potential cyber threats, right? So with this, we finish the first amendment, which is the industrial control system, important amendment from exam angle, right? Thank you.